Now we're going to look at 3.05, compare models. It's our goal. Compare key features of two functions represented in different ways. So you've seen functions represented in graphs, tables, the written function itself, but now we're going to do that same thing and compare them to other functions to figure out information and sometimes related to real life information like this one. We're going to compare and interpret these two linear functions, linear because they're straight lines on a graph, but what's the situation? Well, on the y-axis, we see pages red, and x-axis is always time. So here we have weeks, which should mean that we're talking about the speed at which they're reading. How many pages per week? And that's exactly what we're going to compare. Jordan is reading blank pages per week, and Carson is reading blank pages per week. Let's stop there and figure out how many pages per week each of them is reading. So first up is Jordan. And let's think about how could we find out how many pages per week looking at Jordan's line? Well, here's weeks and here's pages. Those are two parts of information that we need. So how can we get an x value and a y value by finding a point, right? But not just any point, it has to be a point we can clearly see. So if you take a close look at our graph, we can see a very clear point right there at 560. Okay, so 560, well, great. In 5 weeks, he read 60 pages. So how many per 1 week? Well, we could just do a little division. 60 divided by 5 will give us 1 in the denominator if it goes in evenly, right? So if we divide that out, we'll get 12. So Jordan reads 12 pages per week, right? Because this is over 12 pages every 1 week. Let's do the same thing with Carson. Can you find a point? I see one right there. So that's at 460. Same idea. And you can do this with all kinds of things in the real world. Okay, figure out how fast something will get done. That's going to give us 15. So clearly, we now know that who's reading faster? Carson, right? Second bullet point, the book has 300 pages. That's some key information. Blank will finish reading the book blank weeks before blank does. Well, we already know who's going to finish first based off the speed, right? So Carson will finish reading the book blank weeks before Jordan does. But we have one more piece of information to find, and that's how long it takes them to complete the full 300 pages. Well, we know how many pages they complete in 1 week, right? So can't we take, I'm going to just put Carson. I'll put a C for Carson first. Can't we take the total numbers of the book divided by how many pages he's reading per week to find out how long it takes to finish the book? Absolutely. So that's going to be 20. 20 what? 20 weeks for Carson to finish. What about Jordan? Jordan, same book, same pages, but a slightly slower speed, and that results in 25 weeks. Put a little W to remind us of weeks, maybe WK. So how many weeks faster or before did Carson finish? Well, 25 minus 20, 5 weeks prior. Here's our first real life situation comparing two linear lines. Now we're going to compare other features of graphs like domain and range, x-intercepts, asymptotes, and distance traveled. And they're not always in the same form. Here we have function A written out in function form in an equation. Then we have function B represented by a graph. Now, we're also given an equation here. That's not always the case. So that's a helpful piece of information, but let's see what they really want to know. Which description compares the domains of function A and function B correctly? So we don't need to look at the answer choices. We know this question is going to really focus on domain. Okay, let's look at function A first. How do you find the domain of that? Do you remember? Domain is possible x values, right? Do you remember what a parent radical function looks like? Well, if you don't, here's a reminder. You have the starting point at the origin and it goes up and to the right like this. Okay? That's the parent function. If you just had f of x is square root of x, but that's not what we have. There's a transformation and it's right here. We have dishonest h, so that means horizontal movement in which direction? 1 unit to the right. So we're going to take this line and we're going to move it 1 unit to the right. If you didn't remember that, there's a reminder, and you can use Desmos to help you see these graphs. Okay, use it as a tool when you need to. So now we need to compare these, and domain is possible x values. So how far left and how far right? Well, we know this arrow will go up and to the left forever, and this will go up and to the right forever. So the domain of the parabola is all real numbers. We can write it like that or like this, negative infinity to positive infinity. And the domain of, so this is function A. Maybe I'll put function, I'll just put FA for short. Here's function B, okay? And domain of function B, well, it goes as far left as 1, and 1 is included. And then it goes right forever. That's it. Which one of these options? The domains of the two functions are identical? That's definitely, obviously not true. The domain of each is all real numbers. This one is function A, but B is not. C, the only difference in the domains is that one contains negative values. That's true. Function A contains negative values. We see that negative infinity there. And the other does not. That's true. Function B, we see, has no negative values included. So that's our answer. Okay, moving on. The function f of x is represented by the table below. And there's another function modeled by this equation. It's the function g of x, and it's right there. They want to know what's the difference between the y-intercepts of f of x and g of x. Everyone, give it a try. Well, we're talking about y-intercepts. And where are their y-intercepts? Wherever x is equal to 0. So here, when x is 0, y is 3.78. So the y-intercept for this f of x function is, let me just write it out, 1 second. 3.78. G of x, well, didn't we just say y-intercepts are when x is 0? So let's make it 0 and see what happens. We get e to the 0. Anything to the 0 power is 1. And they want to know the difference. Well, we have our two y-intercepts. The word difference in math means subtract. So the difference is 2.78. Ready for a real life problem? Another one? Let's do it. Two trains left a station at the same time. The distance traveled by train A is modeled by the function d of t. We see that here, where d represents distance in miles and t represents time in hours. That's key information. D represents distance in miles, t represents time in hours. Train B traveled a total of 225 miles in 5 hours. And they want to know, how does the distance train A traveled in 2 hours compare to train B? So ultimately, that's the part of what we need to know, in 2 hours. So we're going to start with what we have and see what we can do. This is what they told us about train A. This is what they told us about train B. And we were told T represents time in hours, and they want to know in 2 hours. So we can very easily just substitute 2 in here and find that in 2 hours, train A will travel 106 miles. Okay, that's train A. What about train B? 5 hours. Is there somehow we could divide this to go from 5 to 2? Maybe, but that seems a little complicated, maybe a little confusing. Remember what we did in the beginning? We took the total miles and we divided by the hours to find out how many miles in 1 hour. And isn't it pretty easy to multiply 1 times 2? I'd say so. So let's divide that out and see what we get. You should get 45. And that's miles per hour. Now we want every 2 hours. So all we need to do is take that 45, multiply times 2. So train B will travel 90 miles in 2 hours. So we're looking at option A. The distance train A traveled in 2 hours is greater than the distance train B traveled in the same amount of time. Specifically 16 miles difference, but the answer wasn't that specific, so we are all set and ready to look at a different type of comparison. Now, right now you only see function A. That's because we want to see if we remember how to really see what's going on here. Okay, first and foremost, what kind of function is it? Do you remember? Oh, it's a fraction. And there's an x in the denominator. We call this a rational function because there's a polynomial in the numerator and denominator. Remember, most sets of variables and numbers are polynomials, but there are a few that are not. They're listed here. I don't need to read through them. You can pause and read through them. And you're not going to see them all the time, but you got to be aware of them in case you do. A few of those examples are right here. If you have a square root of a variable in the denominator, that's number 3 here, that is not a polynomial. Or if you have the variable, like here, this x as a power in the denominator, that means that is also not a polynomial. Okay? And that's important to know because if you're comparing functions, you have to know, is this a rational function or something else? Well, because it is a rational function, these are polynomials, we can treat it accordingly. Remember, this is the parent function with all possible transformations, A, H, and V. Okay, well, let's take that information to dissect this a little bit further. We want to figure out what the asymptotes are because ultimately that's what we're going to compare. What are h and v here? That's going to help. Or in other words, what transformations are happening? A rational function parent function looks like this. Nothing changing. Well, the only thing different we see is a plus 5 it with the x. Do you remember what that represented? H, dishonest H, always likes to hang out with X, or maybe it's the other way around. Who knows? But what kind of change does that make? That means H is -5, meaning we had a vertical asymptote in a particular place, and it moved left 5 units, right? So what is the horizontal asymptote if we move left 5? Well, for a parent function, it's right on the y-axis. Our horizontal asymptote always starts with x equals, that's the equation of this line. This is our vertical asymptote. It's x equals -5. And was anything added or subtracted at the end? No. So there was no change to the horizontal asymptote. Horizontal asymptote of the parent function is on the x-axis. So when you have the parent function, quick refresher, this is your horizontal asymptote, this is your vertical. These are lines x is 0 and y is 0. Okay? So vertical at x equals -5, horizontal asymptote at y equals 0. No movement there. Okay. Take that to now answer this. Function A we were working with, function B is right there. Check all the boxes that you feel are true. Now let's go through them one at a time. Here, it'd be good to label what we already knew. We said vertical asymptote at x is -5, horizontal at y equals 0. And if you look at our graph here, wherever you could draw a vertical line and it looks like those red lines won't touch, that's where your vertical asymptote is. So that's at x equals 4. And our horizontal did not move, okay? So that's the same. One vertical asymptote, so which is true for A or B? One vertical asymptote at x equals 4. We see that and we label it in function B. We already wrote out and talked about function A, that is not true. One vertical asymptote at x equals -5. Well, that is true for function A, but not function B. One horizontal asymptote at y equals 5. Do you see VA at y equals 5 anywhere? Nope. So not true for either. One horizontal asymptote at y equals 0. Those are the same. That is true for both. And the next two are not true for either. There are not two vertical asymptotes or two horizontal. That would mean we see something like this if there were two vertical, okay? And something like this if there were two horizontal. That was not the case in either situation. That can happen sometimes, but not today. So those are both out. And finally, one vertical asymptote and one horizontal. Yes, they both have one of each. And finally, the exit ticket. Which comparison in the green box here is correct for the values of f of x and g of x when x equals -3? Look at your answer choices because there was no clear indicator here of what we're looking for. Here we see x-intercepts all over the place. So that's what they want to know. We talked about y-intercepts before. You know how to work with x-intercepts as well. X-intercepts happen when? y is 0, and we know the name of a function is equivalent to y, so here y is 0, so here the x-intercept is 1. So x-intercept at 1. And what about this one? Well, we just said when what? When y is 0, that's where you have your x-intercept. Okay, how do we factor this? How do we work this out? Well, let's see. -2, -2, x squared equals -2. If I take the square root, that's the only way we can get x by itself. We have the square root of a negative number. What does that mean? That means there are no real solutions. There will be imaginary ones, but we only care about real right now, okay? So, what's the answer choice? Both functions have 2 x-intercepts. That's definitely not true. Function A has 2 x-intercepts, and function B has 1. This had no x-intercepts. No real solutions means no x-intercepts. And C, function A has no x-intercepts. That sounds about right. And function B has just the 1. And that's it for 3.05. See you next time.